Hey yo, what's up guys? Welcome to this week's pre-calculus tutorial. Now we're going to tackle about an ellipse. Now let's go right into it.
After this tutorial, you'll be able to define an ellipse, solve for an ellipse, and graph for an ellipse. An ellipse is determined by a constant and two fixed points, each called the focus point. The constant must be greater than the distance between the two foci. The ellipse is determined by two foci and the given constant is a set of points x and y in such plane that the sum of the distances from x and y to the foci is equal to the constant. Now let's go to parts of an ellipse.
The principal axis, a line that goes through the foci. The vertex, a point on the principal axis. Major axis, line segment joining the vertices. Center, midpoint of the major axis. Minor axis, a line segment that is perpendicular to the principal axis. Co-vertex, endpoint of the minor axis.
When the center of the ellipse is at the origin and the first denominator of the equation is bigger than the second, then the major axis is horizontal. But if the first denominator is smaller than the second and it is still centered at the origin, then the major axis is vertical. If the center is not placed in the origin, then you write the equation as shown. Since in the given that 25 is bigger than 16, then we can tell that the major axis is horizontal. Then we can find a and b by finding the square root of a squared and b squared. The answers are 5 and 4. To find c, we use the formula square root of a squared minus b squared. Now we substitute the value, we get square root of 25 minus 16, hence getting the square root of 9, then the value of c is 3. Since a is equal to 5, then we move 5 units away from the center to find the vertex. This is done both to the left and to the right. Now b is equal to 4, so we move 4 units away from the center to find the co-vertex. This is done both upward and downward. Since that c is equal to 3, we move 3 units away from the center to find the foci. This is done both to the left and to the right. Now that we got all the points, we can now connect the dots to form an ellipse. Let's have another example. As you can see in the given, the first denominator is smaller than the second, making the major axis vertical. And the center of the ellipse is placed at coordinates negative 5 and 6. Next is to find the square root of a squared and b squared. After that, we solve for c. We start counting from the center, negative 5 and 6. Since a is equal to 3, we move 3 units, both upward and downward, to find the vertex. Now that b is equal to 2, we move 2 units to the right and to the left to find the co-vertex. Since that c is equal to the square root of 5, we move both upward and downward according to the value. Now that we have all the points, we can now connect the dots to form an ellipse.